Jai Hind all. The topic of today's discussion is virtualization for cloud. So what is virtualization? As this particular thing is already been discussed in unit 1, what is virtualization? So it is the creation of a virtual rather than actual version of something. For example, this something. Now what does this something word means? It means server, desktop, any device, OS, network resources, that is all those resources on the basis of which we can create a cloud. All those resources, they can be virtualized. So in other words, virtualization is a technique which allows to share a single physical instance of a resource or application among multiple customers and organization. It does how it does? It does by assigning a logical name to the physical storage or resource and thus providing a pointer to that physical resource which is demanded, that is which we need to virtualize. So what we are doing, we are not using the actual resource directly, but we are creating a copy or a virtual version of that particular resource and using that version for our cloud applications later on. So virtualization, it is a kind of technology that is rapidly transforming the IT landscape and has changed the way how the people will compute or how the people will use the resources of a particular system. So in this figure, if we look at this figure, this is ordinary machine. And this is a machine which is having a virtualization software, basically meant for creating virtual machines. So if you look at the ordinary machine, we are having the resources, your hardware resources, then OS, and above all we are having the applications. But if we talk about the virtual machine, so here your hardware resources, above that your virtual machine monitor or a virtualization layer set. Now this virtualization layer is known by different names. For example, it is known by virtual machine monitor. It is also known by the name hypervisors or supervisors. So this particular software is responsible for creating the virtual copies of all these hardware resources and thus creating different machines. And these machines are the virtual machines because now this OS in these various VM, for example, this is VM1, this is VM2, this is VM3, and this is VM4. Now all these virtual machines, they are having their own OS. Maybe it is Linux based, maybe it is your Windows based, maybe it is your Mac systems or something else. So all these virtual machines, they are having their own set of operating systems, and these operating systems, they are not interacting with the hardware directly. They are interacting through hypervisor. Here they got the virtual copies of all the resources which this hypervisor has created for these virtual machines. So it reduces hardware utilization. Why? Because if I need to go for these 4 machines, I need these 4 systems available with me. So it will be a costly affair in terms of server, in terms of hardware cost, in terms of licenses of the application, OS, and other things. But here what we are having, we are using the same machine. We are having same set of resources, but we are using these resources, or we could say we are using the virtual versions of these resources to create these 4 virtual machines. So it reduces the hardware utilization, saves energy and cost, and makes it possible to run multiple applications and various OS on the same server at the same time, as this particular figure is showing. It increases the utilizations, efficiency and flexibility of existing computer hardware. So what is the concept behind the virtualization? The creation of a VM over existing OS and hardware is known as hardware virtualization. It is one of the virtualization technique where we are virtualizing the hardware of a particular machine. So a virtual machine provides an environment that is logically separated from the underlying hardware. As in this figure, we have seen that here we are having Linux, it is having Windows, it is having some other. So they are logically separated. That is, whatever user 1 is doing on this system, it is hidden from this particular machine. So it is logically separated. The host virtual machine and the guest virtual machine are the two components that make up a virtual machine. That is, this is your host system and this is my guest system. The guest VM is an independent instance of an OS and associated software and information, as we had seen in the figure. The host VM is the hardware that provides it. That is, it is providing, host is providing computing resources such as processing power, memory, disk, input output devices and so on. So what is the need for virtualization? Virtualization, as we had seen, it is a state of art technology and it is a great boon for the industry which allow performing more with less. The main as well as you could say usual goal of virtualization is to centralize the major and administrative task with parallel improvisation in scalability and load. It saves resources and money. That is the very first requirement, you could say. Every industry has profit making as a major goal. So virtualization gives the industry the same. They are able to achieve more with less. So they, instead of maintaining different servers, desktops or storage, and all the money which is needed to do the investment not only on these resources but also on the maintenance part is reduced, because now we are having only 1 or 2 servers associated and having different virtual machines installed on them. It simplifies management of the data center, because long gone are the days to manage multiple hard drives and data cables. Now with just this single data center, we are able to manage 2 to 3 mega resources and manage zillions of data is fast and easy in this case. Another thing is it has increased the IT productivity and the efficiency. How it has increased the IT productivity and efficiency? Now with the hassle and the wariness of the IT management for big firms, that is, instead of thinking that they have to manage a lot of or a large amount of resources, number of resources had been reduced drastically, and moreover we are having different virtual machines. All these machine versions, they are isolated from each other, so it has increased the IT productivity and also the efficiency of the system. Easy disaster recovery. Now what is happening, if some disaster happen in the system, then only that particular virtual machine got affected. For example, if a person is working on a virtual machine and that virtual machine got compromised, then other virtual machines, since that particular virtual machine is in isolation, is working in isolation with respect to other machines or host system, then in that case only that particular virtual machine can be affected and it can be deleted very easily by the admin, and the admin can create a new virtual machine having all the resources and the facilities corresponding to that compromised virtual machine and allocate that virtual machine to the user. Enhance security, dropping down to less complex system. Now we are having lesser resources, so it implied that less number of resources, they need to be provide security. So how this particular virtualization got possible, how this concept got evolved? This is only possible with the advent of a software which is your hypervisor, it is also known by the name virtualization manager. It is sitting between the hardware and the operating system, and it assigns the amount of access, that is how much resources need to be deployed by a particular application to the virtual machine. What are the advantages of virtualization? Deploying servers too fast, it becomes very easy to deploy the servers in a timely way, because now instead of having multiple servers and initializing them, installing different softwares over them, now what we are having only one server, and having multiple virtual machines running on top of that particular server. So deploying the servers is very fast in this case. Secondly, it saves the energy, that is moving physical server to a virtual machine and consolidating them onto far fewer physical machines, which means lowering monthly power, that is your energy consumption would get lowered down, and also the carbon footprint which it will generate, it also got lowered down. Disaster recovery. So as I had discussed already, that it is very easy, and when your your servers are virtualized with up to date snapshots of your virtual machines, you can quickly get backup and start running. You can roll back your virtual machines, they can roll back to a safe state, and after that you can your machine can start running. An organization can more easily create an affordable replication site, that is the organization, instead of creating the data at a particular or creating the applications on single virtual machine, it can create another virtual machine which is the replica of a previous one. So if one of the virtual machine goes down, then other virtual machine can take its place. Using virtualization for efficient hardware utilization. So virtualization, it has decreased the cost by reducing the need for physical hardware and other resources, and thus we are able to use the hardware in an efficient way. It also lowers the quantities of the hardware, associated maintenance costs, and also reduces the power. You can allocate memory, space, CPU in just a second, and make you more self independent from hardware vendors. Using virtualization to increase, it is also required the availability of the resources. Virtualization platforms offer a number of advanced features that are not available with the physical servers, and which increase the uptime and availability. Although the vendor feature names may be different, they usually offer capabilities, for example, live migration, storage migration, fault tolerance, high availability, distributed resource scheduling, and so on. These technologies give virtual machines the ability to recover from unplanned outages. The ability to move a virtual machine from one server to another is the greatest benefit of virtualization, with far-reaching uses. As the technology continues to mature to the point where it can do long-distance migrations, such as being able to move a virtual machine from one data center to another, is very easy, and low you could say network latency also got reduced. Save space in your server room, because now having 100 of servers, you could have only 30 or 40 servers available with yourself, and thus creating different 10 virtual machines per server you can deploy, or you can meet the need of a larger crowd. Testing and setting up lab environment. For instance, if you are working on an application where certain system testing is required, or certain environment is required, and you are aware that if something goes awry in your code, or in your in your application functioning, then your hardware got destroyed, or it might impact the hardware. Then in that case, instead of working directly over the hardware, it's best to work on the virtual resources, that is your virtual machine, because if something goes bad, then it is the virtual machine which got affected, and your physical hardware, it remain intact. But virtualization has its own limitations also. Extra cost, we had seen the cost, it is as a benefit, but it is also a limitation. And extra cost in what terms? Because you need to invest in a virtualization software, that is our hypervisor, supervisor. You need licenses for them, you need maintenance team to maintain the hypervisor or to maintain the virtual machines which that particular supervisor or hypervisor has created. Software licensing is another thing, limitation, that is if we are virtualizing or creating the virtual machine for a big organization, then at that time software license may be a costly affair. Then learn the new infrastructure, because implementing and managing virtualized environment will require IT staff with expertise in virtual machine. That is, they need to be aware that they are not working over the actual hardware, they are working over the virtual machine. Then how to operate, how to give commands to the system, they must be aware of all these concepts. High upfront expenditures. Initially, if a big organization wants to deploy a large number of virtual machines, then it require a lot of investment in terms of hypervisors, licenses, and other things. So at the initial time, the expenditure is quite high. But yes, in the long run, you can save the money. Not all applications they are ready for the virtualization. There are certain applications available in the market, they won't work on the virtualized resources, they just need the system resources and they need the direct interaction with the system resource, or maybe the supervisor is not ready or to cater their needs, or to convert the APIs which those applications they are running into a host machine instructions. The danger of server sprawling, it says that maybe at the initial time you have to be very careful, you have to decide that how many servers initially you need. For example, you want to deploy a data center and you are aware that you need 30 or 40 servers, then in that case maybe what happened that initially you are working only on few servers, and thus there is a danger with the server sprawling. Types of virtualization, we are having hardware virtualization, network virtualization, storage virtualization, memory, software, data, and desktop virtualization. So what is hardware virtualization? When we are virtualizing the system as a whole, all the resources which are present in your system. In the network, we are virtualizing only the network resources. When we talk about the storage, then only your secondary memory, it is talking about secondary memory. Then memory, it is talking about your primary memory. Software virtualization, that is on the part of software, your programs, your coding. When we talk about the data, then it is your database. When we talk about the desktop, it is your virtual or your hosted system. So what is hardware? It is also known as server virtualization. It is the most common type of virtualization which is used, and the basic idea of this technology is to combine a large number of physical servers into one large physical server, so that the processor can be used more effectively and efficiently. OS that is running on the physical server, it gets converted into well-defined OS that runs on the virtual machine. The hypervisor, in this case, it controls all these resources, and how it does, it allow different OS to run on the same machine without the need for a source code. Hardware virtualization, it is further subdivided into full, para, and partial virtualization. What is full virtualization? In it, the complete simulation of actual hardware takes place to allow the software to run on an unmodified guest operating system. Para virtualization, in this type of virtualization, software unmodified, it runs on a modified OS as a separate system. And in the case of the partial virtualization, in this type of virtualization hardware, the software may need modification to run. In the case of the network virtualization, physical network resources, they are virtualized. This is very helpful in those applications where multi-tenancy concept or the environment has been deployed. So it refers to the management and monitoring of a computer network as a single managerial entity from a single software-based administrator console. It is intended to allow the network optimization of data transfer rates, scalability, reliability, flexibility, security. These are the various advantages of using the network virtualization. It also automates many administrative tasks. The intended result of network virtualization, it provides improved network productivity and efficiency. Network virtualization combined with the hardware, appliances and specific software for the creation and the management of virtual network. Network virtualization can aggregate different physical networks into a single logical network, that is our external network virtualization, or provide network-like functionality to an operating system partition, which is your internal network virtualization. So we are having two categories of network virtualization, internal and external. In internal, uses software containers basically to mimic or provide the functionality of a single physical network, whereas in the case of the external, it combines many networks or a part of a network, parts of a network into a single virtual unit, and thus help in creating virtual LANs, virtual MENs and so on. So next category is storage virtualization. In this type of virtualization, multiple network storage resources are present as a single storage device for the use. So what are the benefits? Improved storage management in a heterogeneous environment, easy updates, better availability, reduced downtime, better storage utilization, automated management, and also it is highly scalable. How it is applied, how it works? These are the different ways for storage. We are having host based storage virtualization, network based and array based. In host based storage virtualization, all the virtualization and management is done at the host level with the help of the software and physical storage. It can be any device or array. Here the host is made up of multiple hosts, that is, we are not having a single host. This is comprised of a large number of hosts, and they are presented as a single virtual drive of a set to the guest machine. Doesn't matter whether they are the VMs in an enterprise or a PC, whether a single user is using that particular system or an organization using that particular system. Network based storage virtualization, here it is the most common form which are used. Devices such as switch or purpose built server connect to all the storage device in a fiber channel storage network and present the storage as a virtual pool. In the case of the array based storage virtualization, here the storage array provides different types of storage which are physical and used as storage tiers, that is in form of multiple tiers. The software is available which handle these arrays amount of storage tier made up of solid state hard drives. In general, we are having other way of describing the storage virtualization is block and file. It is used in context, refers to the abstraction, that is separation of logical storage from physical storage, so that it may be accessed without regard to physical storage or heterogeneous devices. Here the users, they are working on the block, on the raw blocks, they are being virtualized instead of the file. Whereas in the case of the file, what is being virtualized? Your file system is being virtualized, and that particular virtualized file system is being provided to the user for the usage. Memory virtualization. Memory decouples volatile random access resources from individual systems in the data center and then aggregate those resources into a virtualized memory. So by this we are able to provide a shared, distributed or networked function. The memory pool is used by OS or application running on the top of the OS. The distributed memory pool can then be utilized as a high-speed cache or as a messaging layer or a large shared memory resource for a CPU or a GPU application. It enhances the performance by providing greater memory capacity without any addition to the main memory. That is why a portion of the disk drives, they serve as the extension of main memory, that is your virtual memory. It is having two kinds of application implementations. One is application level integration and another one is OS level integration. So in the case of the application level integration, applications, they are running on connected computers, directly connect to the memory pool through, they are using API for this purpose, or they are connected with the file system. So if you look at this particular figure, we are having different contributors, that is different resources. These contributors are different resources, and these has been generalized into a single virtualized memory pool, and on these single virtualized memory pool several applications they are running. So cluster implementing memory virtualization at the application level, contributors, that is 1 to n, they contribute memory to the pool, and the applications, they read or write the data to this pool either using APIs. It could be any language or through the file system API. In the OS level integration, the OS first connects to the memory pool and makes that pooled memory available to the application. That is, applications, if you look at the figure, applications, they are not connected with the virtualized memory pool. What is happening here? The applications first, they are connected to the OS, and this OS is connected with the virtualized memory pool. So cluster implementing memory virtualization, in this case contributors 1 to n contribute memory to the pool, and here OS, it connects to the memory pool through the page caching system. Applications, they consume the pooled memory with the help of operating system. Next category is the software virtualization. It provides the ability to the main computer to run and create one or more virtual environment. It is used to enable a computer system in order to allow a guest OS to run. For instance, for example, letting Linux to run as a guest over a host machine which is having Windows OS or vice versa. We are having different categories of software virtualization: OS, application virtualization and service virtualization. OS virtualization, in OS virtualization, the hardware is used which consists of software on which different OS work. Here OS does not interfere with each other, and each one of them works efficiently. Whereas in the case of the application virtualization is a kind of, you could say, technology which encapsulates the computer program within the OS. It can say that the application virtualizations refer to running application on a thin client. This thin client runs an environment which is totally different from the from what referred to as encapsulating from the OS, which is the location of it. Service virtualization. In the service virtualization, the DevOps team can use the virtual servers rather than the physical one. It emulates, basically here the emulation is being done, no simulation. It emulates the behavior of essential components which will be present in the final production environment. With the help of service virtualization, the complex application, they can go through testing much earlier in the development process. It can say that the service virtualization is a technique to simulate the behavior of some components in a mixture of component based applications. Another category is the data virtualization. Data virtualization, it is an umbrella term for basically your data centers and database virtualization. Here we manipulate the data without requiring the technical details about the data, such as how the data is formatted or physically located. It helps in manipulating the data as it is presented as a separate or independent abstract layer of database system. Without any technical details, you can easily manipulate. So data virtualization software aggregates structured and unstructured data sources. It is important to note that data virtualization does not replicate from source system. It is simply store the metadata and then do the integration for viewing. Vendors are Oracle, TIBCO, Microsoft, and so on. Another category is the desktop virtualization. Here the virtualization technology basically separates the individual PC applications from his or her desktop. So virtualized are generally hosted on remote central server rather than the hard drive of the personal computer, because the client server computing model is used in virtualizing desktops. Desktop virtualization is also known as client virtualization. Desktop virtualization has many benefits: reduced TCO, increased security, reduced energy cost, reduced downtime, and centralized management. But yes, it is having some limitations also: difficulty in maintenance, complexity, cost, and security. These are the few things which act as the limitations for implementing the desktop virtualization. This is all about virtualization for cloud. Thank you and Jai Hind.